In example 1.17, we're going to be taking a closer look at the concept of domain, specifically looking at how domain plays a vital role in the defining of a function. Now, the example here says the following functions are defined without a domain specified. So you'll notice that here in part A, the only thing that I'm providing you with is an equation. So the domain has not been specified. Hence, it is our job to determine what is going to be the largest possible domain of each function. Now, if I give you the domain of a function, I don't necessarily have to give you the largest possible domain, but frequently we will be most interested in what is the largest possible domain. The second part of this example wants us to then define each function using its domain and its equation. Every time you define a function, you need two things to do that. You need a domain, and you have to have the equation. Since I've only provided you with an equation, that means I've only provided you with half of what you need to define the function. That's why we're so interested in trying to find out what is the largest possible domain. So let's spend the majority of the time here talking about domain in a little more detail. When we're talking about domain, we're talking about taking all of the elements from that first set. Now remember, definition 1.10 says that the first set is now called the domain of your function. And your second set is going to be all the values that you end up mapping to, going this direction. Every single value that you map to has to be a real number. Every element from the domain has to map to a real number. That was the note that was in definition 1.10. Now that begs the question, what does not qualify as being a real number? And that can be a little bit of a head scratcher. There are two things that we have to be really careful with. And I say things. When I say things, I mean operations. When you have an equation, you are looking at operations in a particular order. So on this example, let me highlight the operations. You have division, which is indicated by the fraction bar, and you have subtraction. Out of those two operations, only one of them can potentially go awry, and that's the division. There is one division that you cannot do. You are not allowed to divide using 0. Now specifically, you cannot divide with 0 in the denominator. That is not allowed. This is said to be undefined. And that is where we're going to be looking for our domain. So there is always two approaches to finding domain. There is the guess and check method, and there's an algebraic method. I want to start with the algebraic method, and then we'll use the guess and check method to be able to verify the result that we have. So going back to the original equation here, we definitely have a division because of that fraction bar, as we mentioned. The one value that we cannot allow happen in a fraction is we cannot allow the denominator to be 0. That is not allowed. So what I'm going to do algebraically is I'm going to take that denominator and I'm going to set it equal to 0. And then I'm going to solve the equation. And that is going to tell me that x equals 4. And the value x equals 4 is going to be called the domain restriction. So this is not a value that I actually want to include in the domain. It is a value that I want to restrict. So thinking about this from a guess and check perspective, I would make a t-chart and I would start plugging in different real numbers to see what works. Now, according to the algebraic technique, there is one value that is not supposed to work, and that would be 4. So I'm going to start with that one. So for my t-chart, I'll have x on the first column, f of x on the second column, and I will start with 4. So if I plug in 4, I'll have 1 divided by 4 minus 4, which is going to be 1 divided by 0, and that, as we said, is undefined. That checks that the domain restriction is in fact going to be 4. Now you can pick any other real number in the world that you want, and it should work out just fine. So for example, if I pick 1 divided by 1 minus 4 is going to be 1 over negative 3, which is typically written as negative 1/3. Negative 1/3 is a real number. So that means the value that we picked to plug in is going to be a member of the domain. So I would not recommend doing a guess and check method to start. Use the guess and check method to be able to see the verification that your algebraic technique works. Now, as you get more practice with this, you will have more and more trust in the algebraic technique. After all, this is an algebra class. I want you using algebraic techniques as much as possible. And you won't do as much of the guess and check because you'll feel comfortable with the algebra. Now, to summarize the domain, I need to use interval notation. Going back to what we did in example 1.4, we were discussing the idea of infinite sets and having to combine them together. So if I know that x equals 4 represents a domain restriction, let me set up a number line. We're going to call that 4. And if I want to restrict 4, I'm going to put an open boundary at 4. And then I'm going to take all the real numbers that are less than 4 and all the real numbers that are greater than 4. And that is going to represent my domain graphically. That's the illustration of the domain. In order for us to be able to answer the question, we want the domain actually written in interval notation. So I would say that the domain of this function f is negative infinity to 4 union 4 to infinity. And if you need to go back and review example 1.4 so you can get back on the infinite set thinking in that direction, that now would be a good time to do so. But that does answer the first part of this question, which is what is the domain of our function? Largest possible domain. Let me qualify that. Now the last part is wanting us to define the function. And the only way that we can define a function is if we use the domain and we use the equation. Now we have both of those. The first thing that we do when writing a function definition is we have to state the name of the function. In this situation, that has already been decided for us. The name of our function is f. I get that from the equation saying f of x. The next thing I'm going to write is the domain. And the reason why the domain is because these are all the values that will map to some real number. The only value that does not map to a real number is 4, and we are excluding that from the domain. It is a restriction on the domain. So this is what we're looking for at the beginning of a function definition to talk about domain. The second half of the function definition then describes the equation that you would use along with that domain. So then we would write given by f of x equals 1 over x minus 4. And all of that boxed in together represents your function definition. In the upcoming videos, we will look at more function equations, and we will look at doing more domain calculation and some more function defining.